Hey everyone, Richard and Tim here. We are currently students with the Microsoft Software and Systems Academy for the Cloud Application Development course. Today we're going to be going over the whiteboarding process, specifically virtually. The reason that we really decided to make this video is when we came into the course, whiteboarding was a topic that we touched on quite often, but in a virtual environment, not a lot of individuals knew what exactly to expect compared to an actual whiteboard. And we just wanted to kind of give some direction in the steps that we follow when we're solving an algorithm for an interview environment. And hopefully it'll go ahead and help out other students or other individuals who are just getting started with a virtual whiteboarding environment. So with that being said, we're going to go ahead and go through our steps for what we actually do. So our first step is just going to be to understand the task. So when I say understand the task, what I really mean is when an interviewer is telling you something. So if Richard were to tell me, for example, I'm going to pass you an integer array and I want you to find me the sum of that array. So right off the bat, I would want to go and type out those things. So I could just do pass in an int array and return the sum. And then so if you want to, you can ask a clarifying question. Will also be an integer, but since we're being passed integers, it is going to be an integer. All right. And so why this is important, why you should really understand this is, say that Richard were to tell me that I'm going to pass you a sorted list or a sorted array. If I didn't catch the fact that it was sorted, I could go about my algorithm completely differently if I'm comparing two different arrays, and I could end up making it more complex than I really need to. So at this point, really, if you have any questions for the interviewer, if you don't understand the topic, say maybe they're talking about the Fibonacci sequence, this is when you really want to bring it up. And you can even ask, what is the Fibonacci sequence? Because I haven't really worked with that before. So they'll go ahead and explain these things to you. You also want to go ahead and ask, is the thing that's going to pass them be null? Is it going to be empty, you know, if it's a string or anything like that? And remember, throughout this whole entire coding process, you're going to be talking to your interviewer, explaining your thought process, how you're thinking about the code, and then also feel free at any point, if you do have any more questions, you can go ahead and ask them those questions. So now Richard's going to go over our next step.
All right, so for the next step, we're going to be creating some examples for this algorithm. So we want an example. And we want this example to be as big as you think you would need it, and also not easy. So like if you're going to be taking in a sum of arrays, or getting the sum of an integer array, you want to create your example to something like where they are going to be containing some like negative numbers, maybe some zeros, and then positive numbers, maybe some crazy positive number, and it's like essentially like this. So you could make sure that you grab every possible type of integer that's going to be submitted in this code, and this will make it so like as you code, it won't be as difficult when you do run into any issues. Also, make sure that I know they declared, or it was already defined that it was going to be an integer array. So that was going to be the input. I would clarify it. So here we're setting the input equal to the our example, and then we also want to put the output on its own line just to make it so it's clear. And then you want to say, what are we going to output? And as Tim stated earlier, we want an integer. So I'm not, maybe I will. So this is 10,000, and then 3 plus 1 is 4, minus 5 is 999.
Yep.
So that should be the output. And I would continually make sure that you speak to the interviewer and make sure, hey, if this is the input, is this the expected output? And
one more 9 in there.
What is it?
One more 9.
Oh,
it was 10,000.
Oh yeah, 10,000. Yeah.
Mm-hmm.
And then essentially, like Tim said, never stop talking. So you should always be letting them know what's going on in your mind. If there's any long pauses, explain to them why you're pausing, what you're thinking about. So in this example also, so we're clarifying the types, wrote down the input and answer, input and output. And yeah, I think that's it for this step. Tim?
All right, so then our next step is really to go with a brute force approach. So when I say go with brute force approach, I don't necessarily this is going to be your final product at all. This is really just to start coding, and then as you look at your process, you can then optimize it, which Richard is going to be going over later on how to actually do that. So for this example, saying that we're going to be passed into an integer array. So if you want to really break it down, you can do create a signature for method that returns an int and takes in an int array. All right, so we have our signature. So thinking through this, which this is exactly what you would want to do, is explain this. So why I have this is I have it so it'll output that integer and take in an integer array. Now the next thing I'm probably going to have to do is create an int variable and equal it to 0. So why I would want to do that is because we're going to have to find the sum, and we're going to have to store that sum somewhere. So we can go ahead and create that variable. So next thing I'm going to have to think about is how to iterate through that array. So for this case, I can just say I'm going to be using a for loop to step through the array. And then inside the loop, then we're going to say, let's go ahead and create a temp int and equal it to the element of the iteration. And then after that, I can go ahead and do add the temp int to the sum. So those are the things that we're going to have to be doing inside of our loop. So we're just going to go ahead and equate that to a temporary integer for the value of that element of the array. And then we're going to add that value to the sum. And then lastly, we're just going to go ahead and put return the sum. So at this point, this is really your layout. This is really your framework, I should say, of how your code is actually going to be written. So this is where you can look at it. If you're struggling, you can think through the process, and this will just make your coding a lot faster and a lot smoother than you having to delete whole entire code lines and work through it. So Richard is going to go ahead and cover the next step.
All right, so the next step is optimization. And like Tim was saying, with the brute force, you don't have to go out of your way to create a pseudocode that is the worst case scenario. Essentially, you could just go ahead and the first one that comes to your mind that you think would work is what your brute force method is going to be. But in our case, we went ahead and made it a little bit worse than it could be, just because it's a very simple algorithm, and we wanted to optimize it in some way. So for this instance, we did make it a little bit worse than it needed to be. So the next step is optimize. And so to optimize it, we can see here that we're creating a signature, it returns an int, and takes in an int array. That's fine. And then we're going to come down here and it says we're creating an int variable set to 0. So for this one, we don't really actually have to have it. So we could go ahead and skip it. So I'm just going to go ahead and make changes to his code. So we could go ahead and get rid of this one. And then we go into the for loop and we're stepping through the array. And then again, right here, we're creating another temporary integer that's equal to the iteration. Again, we could skip this one as well. And we're skipping it because we could essentially utilize the actual elements in the array to do this. So for this for loop, based on what was given, initially it was going to start at 0 and go until the end of the integer array. But by starting off at 1, we could go ahead and add the second integer in the array to the first one, which is at the 0 location, so index 0. And from there on, we could go ahead and change this entire thing where you're adding the second integer in the array, which is at index 1 right here, and adding it to 0. This is the iterated value. So this is the value that will iterate up and essentially increase every single time it goes through the loop. And then finally, we could return the first index of 0. So like, yeah. So index of 0 of the array. And this way, we make it so we don't have to create unnecessary variables. We're just utilizing what was given to us, and we're essentially cleaning it up. And essentially, this is what you call optimizing. So in optimizing, in this case, we really only changed the space complexity. So the space complexity is essentially how much memory is going to, or how much space it's going to take up to when you run this code. So like if you get passed in an integer array, are we going to create something that essentially stores this integer array? Because if you create something that stores every value in the array, then we're going to say the big O notation of it is n. And we'll be going through these big O notations a little bit more in detail in another video. But in this case, we're going to be kind of briefly describing a couple examples of it. So here in this brute force, or this optimized now, so now we could call it optimized, we can see that we've created no variables, and we've created, and we're using what was handed in. So the space complexity of this would actually be 1, which we call constant. Yeah, and then so the other part of the big O notation would be the time complexity. And the time complexity is about how fast the program will run. So in this case, we are going through every element in the array. So that would be the big O of n. And that's because whatever the input is, which we're going to call n, we're going to step through every single element in the array at least once. So that's where you get this time complexity of O of n. So from here, let's see if I could, so I'm going to go ahead and draw out a couple more big O notations for the time complexity. For the most part, you don't want to create a method that's going to be, that's going to take up essentially all the space on a computer, or like all the space on a drive, or create a method that's going to take up all this time. It's going to take like years to complete. You don't want to do that. So the trade-off here is usually if the space complexity is at a decent spot, so like essentially it's not going to take up too much time or space, then you want to optimize on the time complexity. So if you had a trade-off between creating an extra variable, like a dictionary, so you don't have to create a second loop, that would be a good trade-off. The trade-off would essentially make the space complexity n, but also the time complexity would also stay in n instead of n squared, which was what it would be if there was a nested loop. All right, so I'm going to go ahead and describe a couple more of the big O notations real quick, and then we'll move on. So here we got, so I'm going to go ahead and draw. I'm not very good at drawing, but just a little description. So we got O of 1, which is, we said was constant, and on a graph, it would essentially just look like this. So regardless of the input being put into the function, this will not change. So the second part is O of n. Oh, no, sorry about that. So next we want to look at O of log n. So O of log n essentially looks like this. And it'll start off going up, but it'll taper off and essentially look like that. And I know most people will not like looking at log because they haven't seen it since high school, but it's a simple concept to get once you understand. Once we explain in the next video where we only talk about big O notations. The next one would be, so these are like the most common big O notations that you will see. So this is called a linear time or space complexity, where every single input is going to be created one more time or iterated through one more time based on space or time. And this looks like that. Well, actually, I gave it a little bit more credit than it deserved. It actually looks like that. All right, and then next we got O of n squared. And this would essentially be like the most common case of this would be a nested loop. And this one looks like this, essentially, where it curves up. And the larger the number is, the worse and extremely worse it gets. And then finally, we got O of n factorial. And this would be essentially the worst case scenario. And if you think, why would we create a algorithm or a method that is an O of n factorial? There is one popular algorithm called the traveling salesman, where most people that know how to solve algorithms really well, they think that the best solution is a time complexity of O of n factorial. So these are the most popular. Essentially, this could become O of cubed and get worse and essentially keep going on. And this could also be combined. These could all be combined, essentially. So you could have n log n, and that would be in between n squared and O of n. So you can combine a lot of these. It could be a constant times any of these variables of n's. So it gets a little bit more complicated, but for now, these are the 5 most common ones that you'll be seeing. And we will create another video that describes all of these in much more detail with examples in a future video. So go ahead and clear those out. And Tim?
All right, yeah, so like Richard said, we'll go over that later. Right now, you may be thinking, I don't understand any of that, but it's okay, we'll go over it a little bit. So your next step is going to be to check if your algorithm, we'll just call it algo for short, actually works. And when I say that, we're going to run through our pseudocode here. So this is where that example input comes into play. You can be referencing it throughout the time that you create your pseudocode. Kind of helps you get that little bit of visualization. So if I go ahead and step through this logically, we have our signature, so I know that this is going to be our input, and we're going to have an integer as an output. So now we're going to go and we're going to start at the second element of the array, so 0, and we're going to be adding it to our first element. Let's go ahead and take out that really fast. So we're going to be adding it to our first element, so -5. So when we add 0 to -5, it's still going to be 0. And then that for loop is going to iterate through the next time. And then we're just going to be adding the next element, so 1 to -5. So now we have -4. And then we're going to be doing 1,000. So subtract 4 from that. So then that'll be 9,996. And then when we add in the 3 during the next iteration, then we'll get 9,999. So through that process, we just verified that with our example input and our example output with our algorithm, we have gotten the correct answer. So then the next step is going to be to actually build your code, which Richard is going to go over.
All right, so the next step is step 6, and we're actually going to code our algorithm. So now that we've came up with the solution up here, and then we optimized it, and then made sure, double check that it worked, we're going to go ahead and start coding. And the tips for coding is that you want to start off with a pattern, like so a style of coding, and stick with it. Also, you want to make it as clear as possible. So we're just going to go ahead and put some notes here. Clear, make it clear to read. So you want to make it simple to read for the interviewer, and also it helps yourself as you code, so you don't get confused while you're writing it or typing it up, in our case. Also, another second small tip would be when you get these parentheses, go ahead and open and close it, and then type in between it. That way you don't end up forgetting a closing brace later on, and essentially could get confused, because if you wanted something outside of a loop, but it looks like it's inside the loop, and the interviewer is like looking at it like, oh, why did you put that in the loop? It's not going to get the right answer. So if you open and close your brackets at the same time every time, it'll be more beneficial to you and clear to understand. Next, I would say the tab styling. So like, if you're going to be inside the brackets, you don't have to put the brackets like this. You could put it like this if you want. I always prefer, but stick to one or the other. Don't go back and forth where people can't see what you're doing or understand it. And then tabbing, if you tab in here, if it's inside the brackets, bring it in one tab. If you're going to make another one here, you don't want to do this, like I said earlier. You want to bring this one down since the other one is already down. And you want to come over here and tab again. This just makes it so you can see what's where, essentially. The next one would be the naming convention. So make sure that if it's, you don't have to do it exactly like we do, but what we follow is that if it's a public variable, then we use Pascal case. If I could spell, such as this, so where every letter, every word in the variable name is capitalized. And then if it's a private, then we do camel case. So the first letter of the first word is lowercase, and then after that, all the other letters are capitalized. So if there was a camel case example, then we do like that. So we're going to continue to capitalize every word after the first word. Next, you want to make these variable names as descriptive as possible. So if you were taking the sum of it, so far we didn't create any variables in our example, but if we were to create a variable in our test, our example method up there, we would want to say, hey, this is the, and you don't really need to make it public. So it'll be a private variable. So we're going to go ahead, and private variables are already, if you create a variable without declaring it as public, it starts off as private. So if you say we're going to create an integer, and we're going to say it's going to be the sum of the integers, you could say it's going to be the sum of elements. That way you could see it, you know exactly what it is, and you won't have to second guess if this is what it did or something else, it did something else. This is clearly going to be the sum of the elements in that array. Now, if you start creating these variables and you want to be as descriptive as possible, and they start becoming extra long, like sum of elements in the array of integers, something like that. If you have to make it that long, and you think that's the best way to declare this variable, you could start off with a with it like this, and then be like, hey, ask the interviewer if you could abbreviate it. So ask the interviewer to abbreviate. In future, abbreviate. And any future times you call it. So like, let's say you want to call it something else, like sum. Then you could be like, hey, is it all right? I know the importance of descriptive variable names, so I named it like this. But would it be all right, for time's sake, if we could use the word sum for any future times I call this variable? And it's really up to the interviewer to say yes or no. If they say no, then you just gotta go ahead and start using this as your variable from there on out. But the more descriptive variable would be the better way to go. Finally, modularize before, not after you code. So if you're going to go ahead and you have to sort your algorithm, so you get two integer arrays, and you have to sort it before you do some other what is it called, calculation to that sorted integer, then go ahead and separate it out into a helper method. So create a helper method to sort the array, and then call that method in the other array, other method. This will help it make it so it's clear to understand, and essentially you're separating it out so you don't have to so it doesn't get confusing, really. So like if you have a helper method called sort the array, then you know that this method is going to sort the array. So when you call to it in the other method, you won't have to worry about it later on. And then next, you're going to want to test, and Tim is going to walk through that part.
Okay. So for this case, I'll just go ahead, and for the actual coding out, so if we went and did that, so create that signature, so we'll just say, call it a public static int, and we'll call it get sum, since it is public, as Richard already stated. And then we're going to pass it that integer, and we'll just call it, for this case scenario, we'll call it the input array. Oh. All right, and then just as Richard already stated, for our brackets, we're going to go ahead and create those and close them out. And at this point, we're going to be following that pseudocode that Richard already went ahead and optimized. So if we're doing that, then we're going to do a for loop, I equals 1, since we're going to the second element. And then we're going to do the input array dot length, and we'll iterate up it each time. And then once again, like Richard said, we want to keep this styling consistent throughout. So keeping those curly braces down below. And then for this case, we are just going to do input array, and then we're going to do 0, and then plus equals, and then the input array, and we're going to do I. All right, so this is the point where you're going to go ahead and test your code. And then, sorry, down at the bottom here, we got to put return input array, and then the first element of that array. So this is a point where you're going to go through and actually test your code. And before you even start really running through it, you want to skim over it. So make sure that you didn't leave off a curly brace if you had forgotten to add that right off the bat. Or make sure that I didn't capitalize int up here on accident, but I didn't do it down below. Make sure that pretty much your syntax is correct and there's not any obvious errors to you. So then you're going to start off with a smaller test case. And the reason why we're going to start off with a different test case is because we have pretty much used this this sample input right here to create our code initially. So we want to ensure that we didn't create a code that's only going to work for one input. So let's say our input 1 is going to be a simple array that is just 4, 5, let's do 1, and then 2. All right, so then we're going to go ahead and say, well, 4 plus 5 is 9, plus 1 is going to be 10, and then this should equal 12. So when we're going to go ahead and run through that, so we have 4, then we're going to be adding the second element to that 4, getting 9, iterate through it within our loop. So 1 is going to go in there, so then 10, and then we're going to go through again and add that 2 to that same element. And then we're going to return that first element, which is our answer 12. And then we're going to go ahead and create a little bit longer test cases. So let's say our input, and all of these are going to be time dependent. So if you're running short on time, you aren't going to necessarily keep doing more and more and more test cases. Your interviewer may tell you just to stop, and that's okay. But if you add all these, and then you're going to be really running through it. And for time's sake of this video, I'm not going to add up all these. And then, so you want to start off with the short one, go a little bit longer, and then you want to do any outlier cases. So say that you're going to go and do your input 3, and you want to do anything that you may think be an outlier. For this one, there's not many, so maybe you think that a negative number, a high negative number could be an issue. So then you can go and test that and ensure that your code still works for any outlier cases. And once you go through and you verify that your code works for a variety of inputs, you've tested that your code works. And the last thing to say here is, if you're going through this and say that since we built it around this input right here, maybe we made a mistake and we didn't necessarily do it right, say that we added it to a value that we set. And you're going and you find out that one of these inputs does not work. If you do that, then you've just found a bug in your code. And when you think about how to fix your bug, you just want to ensure that you're fixing it for a wide variety of test cases. You don't just want to fix it for that one test case because you didn't really fix your code. You just went ahead and put a Band-Aid on it. So whenever you go back and fix any code, make sure that you do that. Also, if you're running through your code and you realize that you missed a semicolon and you didn't correct it the first time, just go ahead and add that in there and state that. Remembering that throughout this whole entire process, you're going to be talking to your interviewer, making sure that they understand what you are doing and why you're doing it. So those are the whole entire steps to solve an algorithm. So 1, you're going to want to understand that task, ask those clarifying questions. 2, create an example input and output. 3, brute force it, so pretty much solve it any way that you can think of, then optimize it, minimizing that space and time complexity. Then go ahead, run through that pseudocode, see if it works based off your input code, then actually code it out. And lastly, you're going to go ahead and test it, which I had forgotten to put here, but you're going to test it. All right. Richard, do you have any additional comments?
No, I think we covered it all.
All right, yeah, we're going to be working on some more videos. If you guys like this one and want more, go ahead and drop it in the comment, and we'll look at it and do our best to help you guys out. Thank you.
Thank you, guys. See you.